Hi everyone, Tarulli Tutoring here. Today we are going to go through the proof for the derivative of tangent x. So if you have your math textbook, your calculus textbook, you are probably aware that the derivative of tangent x is equal to secant squared x. But we're going to go through how we got this. What is the proof for this? Okay, so the first thing we need to know for this proof is that we can write tangent x as sine x over cosine x. We should have seen this in past grades of math. This shouldn't be new information, but in case you've never seen this, we need this to start. And we're going to take this and sub this in, oops, sorry, that was an ugly circle. We're going to take this and we're going to sub it in for tan x. All right, so we're going to say d dx of sine x over cosine x. Okay, so now that we have this, we have a fraction, right? Whenever we have a fraction and we want to take the derivative of it, we want to use quotient rule. If you're not familiar with quotient rule, this is how it goes. So say we're taking the derivative of this fraction, f over g. Applying the quotient rule, we would get the derivative, which is f, derivative of f times g minus derivative of g times f all over g squared. So we're going to apply this quotient rule to our fraction with sine x over cosine x. All right, let's do that. So the derivative of sine x is cosine x, and the derivative of cosine x is negative sine x. So we're going to need that when we apply quotient rule. Okay, now that we've gotten this all out of the way, let's go and apply this rule. So our f is sine x, so the derivative of that is cosine x, times g, which is also cosine x, and then minus derivative of g, which is negative sine x, times f, which is sine x. Okay, and then that's all over cosine squared x, right? Because we square whatever's in the bottom. All right, if we simplify this a little bit, I'm going to scroll down a little bit, make some room. We'll put this little line here to separate our forward from our actual proof. All right, so if we simplify on the top in our numerator, we have cosine squared x minus sine squared x all over cosine squared x. All right, if we distribute this negative, we get cosine squared x plus sine squared x all over cosine squared x. Okay, if we remember, we have this identity that says that cosine squared x plus sine squared x is equal to 1. This is the Pythagorean identity. We're going to use this now. And instead of saying this, we are going to say 1. All right, so let's sub that in. So then we get 1 over cosine squared x. Well, if we recall, 1 over cosine x is equal to secant x. So 1 over cosine squared x should be equal to secant squared x. So let's go ahead and write that. Secant squared x. So now we've arrived at our desired result of secant squared x, and that concludes our proof. I hope this video was helpful, and if it was, please leave a like and a subscribe down below. I thank you for your support of this channel, and I hope to see you in the next video. Bye.